Now we'll look at applications called work rate problems. Here's an example of a work rate problem. Painting a house. One painter can paint a house in 8 days, yet a more experienced painter can paint the house in 4 days. How long will it take the two painters working together to paint the house? If we had just the first painter painting the house, we know that the house would be finished in 8 days. If we had just the second painter painting the house, we know we'd be finished in 4 days. However, finding the time it takes for them to work together is a little bit more of a problem. What is the rate that the first person can paint the house? Isn't it 1/8? They're painting 1/8 of the house every day. The more experienced painter is painting at a rate of 1/4 a house a day. The thing is, we're not sure how long it's going to take them together to paint the house. So what we do know is it's going to take them a certain time to paint the house together. The first painter does T/8 of the work. The second painter does T/4 of the work. If we take the fraction that each one of them painted on the house and add them, they will have painted one house, or finished one job. If we can solve this for T, then we'll know how much time it took them together. A general formula is T/A plus T/B equals 1. T is the time spent working on the job together. A is person A's time. And B is person B's time. All you need to do is put the appropriate numbers in the formula and solve. Let's go back to our house painting problem. One painter can paint a house in 8 days, and a more experienced painter can paint the house in 4 days. How long will it take the two painters working together to paint the house? We start with our formula, T/A plus T/B, and it equals 1. The thing we're solving for is how much time it takes together to paint the house, so T will be our variable. T is the time that it takes together to paint the house. Now we just need to substitute the appropriate values in for A and B. That gives us T/8 plus T/4 equals 1. Now looking at this, I see the LCD is 8. So I'll multiply each term by 8. 8 cancels 8, and I get T. Plus 4 cancels 8 twice. I have 2T equals 8. Solving, I get 3T equals 8, and T is 8/3. We wouldn't leave our answer like this because it's a word problem. We need to go ahead and turn this into a mixed number. 8/3 is the same as 2 and 2/3. And what is our label? It's a time label, and we know that the time was in days. So this will be 2 and 2/3 days. Distance rate time problems. This one is on river current. A boat can travel 36 miles upstream in the same time that it can travel 54 miles downstream. If the speed of the current is 3 miles per hour, find the speed of the boat without a current. We have two situations. We have the situation where the boat is going upstream, and the other situation is where the boat is going downstream. Now we have distance equals rate times time. I'm going to fill out this chart with whatever is given to me in the problem. In the upstream trip, we have the boat traveling 36 miles, so we'll put that under distance and across on the same line of upstream, 36. Traveling 54 miles downstream. So, underneath distance and in level with downstream, I'll put my 54. The speed of the current is 3 miles per hour. We're to find the speed of the boat without a current. Right now is an appropriate time to define your variable. What are we going to let x represent in this problem? We know the speed of the current is 3 miles per hour. We don't know the speed of the boat. So let x equal the speed of the boat without a current. Now think about going downstream. If the speed of the boat is x and the speed of the current is 3 miles per hour, then my overall speed would not be just x, it'd be 3 miles per hour faster. So its overall speed is x plus 3. Going upstream, my boat is trying to go x miles per hour, but the speed of the stream is pushing against it 3 miles per hour. I'm not given anything in time, except that the problem says that this trip upstream and downstream is done in the same time. I do know that time is distance divided by rate. To see this, let's take the formula distance equals rate times time and solve it for time. We'll divide both sides by r, and t equals d over r. Now let's take this distance, divide it by this rate, and that will be the time that we put in the chart. Here I'll take this distance and divide by its rate, x plus 3. Now the problem says that the trip upstream and downstream is done in the same time. That means this time is equal to this time. Now we see we have an equation. 36 over x minus 3 equals 54 over x plus 3. Now we have a proportion where a single fraction equals a single fraction. We can simply cross multiply, which gives me 36x plus 108 equals 54x minus 162. Now we need to get our x's on the same side. So let's subtract 36x from both sides and add 162 to both sides. This is going to give me 18x on the right. On the left, I'll have 270. Now I'm ready to divide by 18. When I divide 270 by 18, I get 15. X equals 15. Let's make sure that this makes sense in the context of the problem. If I'm going upstream, I have 15 minus 3 is 12 miles an hour going upstream, and 15 plus 3 is 18 miles per hour going downstream. So we know that the answer is 15 miles per hour. A similar distance rate time problem is an airplane speed problem. It's just that the travel medium is now air instead of water. An airplane can travel 450 miles into the wind in the same time that it can travel 750 miles with the wind. If the wind speed is 50 miles per hour, find the speed of the airplane without any wind. So now we have two different situations. We're traveling into the wind and traveling with the wind. Into the wind is the same thing as against the wind or against a current. So we're going into the wind and going with the wind, where the wind is helping us. Distance equals rate times time, and let's fill out our chart. We have 450 miles into the wind, and we have 750 miles with the wind. The wind speed is 50 miles per hour. Find the speed of the airplane without any wind. Let's go ahead and define the variable. We're going to let x equal the speed of the airplane without wind. Now, if I'm going with the wind, I know my plane is going X miles an hour, but the wind is pushing it an extra 50 miles per hour, so it's X plus 50. Into the wind, I'm trying to go X miles per hour, but the wind is pushing me back 50 miles per hour. The same as we did last time, we know that time is distance divided by rate. So this time is 450 over X minus 50. This time is 750 divided by X plus 50. Reading the problem again, we see that we can travel 450 miles into the wind in the same time that it can travel 750 miles with the wind. This means that, again, my times are equal. 450 over X minus 50 equals 750 over X plus 50. Now that I have a proportion, I can go ahead and cross multiply. 450 X plus 22,500 equals 750 X minus 37,500. Now I'm going to get my x's on the same side, any terms that don't have a variable on the other. This gives me a 300x on the right, and on the left I'll add 37,500. This gives me 60,000. Now when I divide by 300, I'll have 200. So the speed of my plane without the wind is 200 miles per hour. This problem is a word problem consisting of just simple substitution and interpretation. If a car is traveling downhill at 30 miles per hour on wet pavement, then the braking distance b in feet given for this car is given by b equals 30 divided by 0.3 plus m, where m less than 0 is the slope of the hill. Find the braking distance for m equals negative 0.05 and interpret the result. All we need to do is substitute negative 0.05 in for m. So in part A, I'll have b equals 30 over 0.3 plus a negative 0.05. That is 30 divided by 0.25. So b equals 120. Let's make sure and label the answer. We were finding the braking distance, and the braking distance was given in feet. So this will be 120 feet. In part B, find m if the braking distance is 150 feet. The value that they've given us is not m. It is a braking distance, which is b. So we'll put 150 in for b. Now we need to solve for m. If you want, you can go ahead and cross multiply. We'll have 30 equals 45 plus 150m. Now we need to subtract 45. That gives me a negative 15 equals 150m. Dividing by 150 on both sides, I get m equals a negative 0.1. So m has a value of negative 0.1 if the braking distance is 150 feet. Go ahead and try the homework and let me know if you have any questions.